Hello, my name is Emanuele and I'm an architecture student from the Universidade Federal de Santa Catarina. I'm a member of the research group called Virtuab and I do research about materials classification in furniture design. I'm gonna give you a little introduction about my article. The materials classification increases in complexity as new materials are constantly released on the market. The furniture designer, usually an architect or designer, needs to stay current with the emergence of new wood panels, composite metal alloys, and others. The choice of the materials is a crucial moment in the project as it marks the transition between the conceptual project to the actual project. The currently available classifications are generalist and, strictly speaking, fit for any product. However, the practice shows a difficulty in selecting the most appropriate materials considering the specific area of each project. The article aims to demonstrate the difficulty of the available tables and showcases studies of furniture projects and finally presents a classification proposal. In the past years has increased the importance of the materials in design. Only in the last 3 years have been published by the main Brazilian publishers 23 books whose theme is materials and processes related to design, architecture, and engineering. Besides that, a large number of scientific articles have been published in annals of events and periodicals. Authors like Callister Jr. and Hatchwich present a detailed and complete overview of materials that are used in almost all engineering, design, and architecture courses in the country. For the others, the traditional classification begins by grouping the materials into 3 large groups: metals, ceramics, and polymers. The initial way is based mainly on the chemical composition and the atomic structure of the base materials. In the part referring to polymers, the authors divide them into synthetic and natural, including in the natural group those derived from plants or animals, such as wood, bamboo, rubber, cotton, leather, silk, and others. The periodic table currently has 118 elements, many known and used for centuries for material obtaining. The difficulty of the material classification can be exemplified with these 2 elements. Being a binary alloy of iron and carbon itself, is divided into several types according to the quantity of iron and carbon with different characteristics of hardness, mechanical strength, malleability, and ductility, among others. It is estimated that in 2017, more than 300 new types of steel were tested, of which only a small portion is likely to be available for industrial uses. Ferrari and other authors present a classificatory table of materials in order to facilitate the selection process. It serves as the basis for the beginning of the process, whose method is demonstrated in the website of Sustainable Materialteca of the university, that is in constant adaptation, establishing a relationship with the systematics used in design projects. The tables are more suitable in the methodological stages of conception. About the group called traditional materials, which independently of the authorship usually includes woods, metals, plastics, and ceramics, continues to have a priority, although not as much as in older publications. It should be noted that the priority is more pronounced in books than in articles, considering the focus of each publication and the average time elapsed in the editing of the original manuscripts. The wood is contemplated in many publications and in design the most time. The wood is contemplated in many publications, and in design the most used are Pereira, which presents a general overview with technical and aesthetic characteristics of Brazilian trees, and Senai, whose emphasis on furniture design makes it an important query source. There are still others, such as Ashby and Johnson, who in addition to the comprehensive book with all material groups have developed in partnership with other researchers the granted design softwares, which among other things allows the designer a comparative visual analysis between quantitative and qualitative attributes of different materials. Eu não lembro a pronúncia de quantitativo mesmo. The tables are complemented by physical samples, which allow the user to a tactile experimentation, and by datasheets of each material that present a brief introduction of the material, focusing on the life cycle analysis. They follow basic concepts, properties, characteristics, a brief story of the material, and main types classified according to the national and international standards. In a section on ferrous metals, Chiaverini presents in detail the influence of the chemical elements added in the iron carbon-based alloy, in addition to the thermal and surface treatments. Unlike the first editions, where the focus was steel and cast iron, in the latest versions, non-ferrous metals are increasingly present. However, there is still a very great emphasis on mechanical building materials, and designers seeking information on light alloys involving copper, tin, and noble metals, for example, is not the source of most appropriate consultation. Barbosa meets the need in the most non-ferrous metals, covering aluminum alloys, copper, nickel, titanium, magnesium, lead, zinc, cobalt, zirconium, and niobium. The need of laboratory or factory manipulation of chemical elements added in steel, aluminum, polymeric, or ceramic alloys inhibits amateur attempts. This not occur on the manipulation of materials such as tree bark, coconut fiber, sugarcane, horsehair, or even bamboo. The ease of processing and obtaining the material, possibility of using common workshop machinery, lack of normalization processes, and access to the material in the nature facilitated the free trial. Another aspect to be observed concerns the time of research and development to which the material is submitted. While traditional materials have a history of more than 200 years of research, many of the alternative material service count for a few years, at most a few decades. Furniture refers to woods. This popular view is directly related to the historical use of wood in furniture as its main material. It is also influenced by the fact that only the furniture in the residential furniture group is considered as a mobile. Only came later the inclusion of other types of furniture, especially the urban. Firstly, it's necessary to separate the groups of furniture that will be considered here. The groups were defined mainly considering the aspects of the use. There are residential furniture that are designed for indoor use with a few users, usually families, nucleus, and gases, with non-aggressive environments and little exposure to inclement weather. The second one is internal condominium furniture, designed for indoors but with many users. The environment is not so aggressive, not subject to weather, but the material is more subject to wear by shared and more intense use. The third one is external condominium furniture. It's used for outdoor use with many users but a controlled public, with aggressive environment and subjected to weather whereby shared and intense use. The fourth one is the street furniture, designed for outdoor use with many users in open access to public spaces. It's like in squares, walkways, bridges, parking lots, and others. The environment is aggressive and subject to inclement weather and possibility of vandalism with heavy use. In the area of furniture design, designers such as Philip Stark, Fernando and Roberto Campana, Enzo Marie and Tom Dixon and others use very different materials in their projects. The simplistic view of the use of the materials, such as wood for the body of furniture, fabric for the upholstery, and metals in the hardware, commonly used in design descriptions of the catalogs, is no longer accepted. A more detailed specification is needed, especially nowadays with an increasing alert of the environment questions. A description of the origin and artificially of the materials used can be decisive in the purchase process. Aware of this, current designers are increasingly seeking to use natural materials with less impact to the environment. The constant releases of materials called alternative materials further increase the field of study. Materials such as bamboo, coconut fiber, sisal, and others are increasingly present in the furniture. Most of these materials still lack accurate and reliable information. While research on traditional materials requires laboratories, controlled environments, and skilled labor, this is not necessarily the case when it comes to alternative materials, whose case studies are often described on blogs and specialized websites. Considering the exposed, it's verified that the way that materials are classified does not meet the expectations and needs of the furniture designers. The classification tables are, in general, very complex and approach materials that are not used for the specific proposed studied here. The first moment for the proposal of classification was the division between the furniture categories previously described, like residential, condominial internal, condominial external, and urban. For the classification of materials were studied properties, general characteristics, strengths, limitations, and everyday examples of use of each materials. As far as possible, physical samples of the materials were analyzed whenever possible to verify characteristics such as tactile issues like softness, roughness, thermal sensation on the touch, beauty, smell, and others. For the final composition of the table, after the initial separation into groups of furniture, the next step was a survey of the material supply market, considering facts such as ease of manufacturing, the degree of specialization of labor, machinery, direct acquisition costs and transport, indirect costs, quantity of suppliers, supply, demand, environmental legislation, recycling factor, life cycle analysis, aesthetic issues, and comfort and safety in use. The table that we talked about before was used as start point for the preparation of the proposal. The primary analysis reduced from 18 to 7 tables. After this step, the materials were classified according to the suggest group and subjective criteria were adopted to determine the factors. The factors were originated from the FEM tool. The factors that were used were manufacturing and productive, marketing and social services, economic and financial, aesthetic and productive presentation, ergonomic and safety, and ecological. Here we have one of the tables. This one is for natural and transformed wood for residential furniture, and they relate the determinant factors that I said before with types of wood like pine, cypress, canela, and others. The purpose of this article was to show the development of the tables to choose materials with a focus on furniture design. It initially demonstrated a history of the traditional materials gradually being replaced by supplemented by alternative materials. This created a problem for material selection because of the difference in relevant and reliable information data between the various material groups. Based on the previous applications, the authors developed several practical tables that seek to guide the designer in the choice of materials, establishing correlations with factors of fabrication, productivity, aesthetics, market, society, environmental, economic, safety, and costs. primarily application studies conducted to date indicate the need to test the tables in the 4 furniture groups in the last 3 to 5 different product design situations. These tests have already been started with the application of the university product design classes.